pipe is able to sustain the fluid pressure or air pressure or not, or it needs some change in the design. And advantage is that if one particular design parameter changes, if I say my diameter of the pipeline changes, maybe say 4 inch to 6 inch, then all connected items which are connected to that, they also need to be changed and updated. So user may not need to have to do those change manually, but it happens across the pipe specific as per the pipe specification. Like if I say I change the pipe from 4 inch to a 6 inch size, the connected elbows, the connected fittings, valves. It's not like I do it piece by piece, one by one, and I have 100 items connected, and certainly 50 of them were left out. Then generating a report basically for bill of material, data sheets, valves list, equipment list, what all you are going to. Before even discussing together all this, I'll just show a glimpse of one of the project which we created recently. If you see this plant, it is just looking like having pipes and steel platforms. Can you see number of pipes and all we have? You will get an idea like what kind of work I am talking and how the overall process happens for them. So you see how many components are there. There are vessels meant for different purpose, vessels or tanks, you can say. You can go close and you can see the railings, guardings, and all that created for them. Different size of connectors, the nozzles, and their fitting, and all the assembly related to that, the flanges. And you will see lots of components. And these are not just small components. These are spread across kilometers. If I reduce the size, and probably you will be able to see the part of the plant on the other side. Yeah, this one. It is not just a small. The pipes are running across kilometers, where the main unloading raw material tanks are there. From there, they come across various pipelines and other thing, and then they come to the filtration, or they come for the condensation plants or the desalination for water related things. So they are all very large assemblies in terms of process design, and everything will be synchronized. So at times when the pressure in a vessel is going to change, it is going to increase, then what effect it generates to the other object. So that is the work where we talk in terms of the database connectivity. The pump's data should go to the motor or the pressure in the tank should go to the sensor, and the sensor will take care, or it will at least let you know that if the pressure is going to be too high and there are any leakages or any blast or any problem which can happen in such conditions and such situation. So this is just a glimpse quickly, like how these plants are defined. This is not a power plant. This, I guess, is related to for some water desalination plant and stuff like that, and different stages are defined. So there are various modules or tasks which are defined for different activities. So something like the process starts from the proposal, from the project document and reviews. Such plants, like they will have a few 100,000 of drawings related to them. Each object will be detailed. Each object will be explained, like what kind of process it is handling, what size and information it has, who is the manufacturer, supplier, is lead time to delivery in the plant, when it will be available for delivery, like that. So we start with the basic engineering, the setup and structuring, then we define the specifications for them, each pipeline and the tanks. Then the primary layout is defined, which vessel will be placed, what kind of orientation it will have, what is the plant north direction, so that the actual structural activities could be defined. Then calculations are done. Then we also have certain things which are known as the catalog manager, where we add the data received from the manufacturers and suppliers and auto vendors. where we add that information, and user or the designer need not have to keep typing it again and again. There may be typing mistakes. So we make a standard catalog, and he just need to connect it. He just need to link the data with the right object. So he gets that data, and that way you can say it is kind of standardizing the process. If he says he only has to buy 50 HP and 70 HP pumps, then he's not going to select anything as 20 HP or 10 HP. He will get only thing which is defined in the catalog. Then it links with the ERP. All these purchasing and such things are controlled to the ERP activities. And it has like data from the design act tools, the Cadison, it is transferred to the ERP. ERP does the vendor management, object management, deliveries and all. And then it is sent back to the Cadison so that even the designer will know, I have ordered an item which is expected to be delivered after 20 days. So today's date, considering the December 1st, can I get it on December 28th, or is there a change on the schedule? If it is getting delivered on 28th, then I should be in the plant on 21st so that I can think about doing the assembling of that, not before, because otherwise it is not available. If I go on 10th and 15th, it is not yet available. So it doesn't make sense. So how can you plan the resources within the plant? So right from beginning, from some basic understanding. So just, okay, before that, so giving some theoretical understanding. So process plant is building and altering, Okay, building and altering industry facilities, layout, equipment, procedures to efficiently convert the raw material into finished industry products, how it should be ready, and then how are you going to ship it out. And process requires understanding engineering disciplines, mechanical, civil, electrical, chemical, everyone. Now even the IoT, you say the digital twins, people are working. If I have a plant of capacity, suppose 50 tons of production output every day, and I want it to be scaled to 500 tons, what all changes I need to do? And can I simulate it digitally before the actual plant is made? So yes, that is possible with the digital twins. So not only one discipline, it is not something like a developer or a programmer sits and does something and he happily, oh, I have done something. No, it will fail always. So many people are integrated, or they are allowed or made to work together so that you get the plant out of it. So the conceptual planning, determining the plant's objective, production, the capacity, and the overall purpose is important, and that is what we control for this, our tool. Once the concept is established, thorough engineering process begins, includes the defining equipment, systems, the instrumentation, control methods, and they work together to ensure the plant's efficiency, safety, very much important, and the environmental sustainability. It should not be emitting too much of a smoke or too much of wastewater, which is one of the problem statements which I had listed, recovery and reclamation of water from the wastewater, because they all lead to more problems than the advantages. So during this process, from design perspective, what all we do, that we first start with the process flow diagram, the PFD. Then we convert them to instrumentation diagram, the process with the instrumentation diagram, the PNIDs. Then we also do lots of material and energy balance, how much energy is required, what kind of material, the fluid or the gas will be passed through, basically for the intake and production of material perspective. Whereas the energy balance, same as the name implies, measures energy consumption and the generation needed. Whether a 50 kilowatt or 50,000 kilowatt plant will be sufficient, I have sufficient transformers and power supply line, or something higher is required or lower is required, so that we have a balanced information out of it. Then the equipment design and selection, you can read, basically, I'm not going to repeat it again and again. You can read meanwhile. The process simulation and optimization, lots of things which can do simulation of even of the process, even without the process actually happening. So on your laptop or desktop screen, you can simulate those things and get an idea at what point the pressure is going to change or pressure is going to increase. If it is increasing, what is the amount of that? Or if it is decreasing, what was expected, probably your input was too low and it is making backlog or vacuum or bubble out of it. And always the safety and environmental condition. There's no high pressure item leakage or blast of the furnace or blast of the vessels and all. You may have heard frequently, like one particular plant, some chemical plant, some furnace or what is it, the tank blast happens and 4 or 5 workers were injured badly, or even some unexpected things happened. So everything, this also is very much important. Just to give an idea, like what all places we are referring to. So chemical and petrochemical plants, oil and gas based plants, pharmaceuticals, they also have lots of chemical operation activities happening, food and beverage, environmental engineering, the renewable energy cycle, mining metallurgy. I think I should have mentioned water and wastewater treatment. Likewise, this is just a list, a small list. You can keep adding everywhere. So going down, when I said in the 2 slides back, okay, here, like we start with the process flow diagram, then PNID, then the material energy balance, equipment design, process safety. So this is just an idea. When we talk in terms of design activities, what is the level of detailing or design which is covered, and how are we going to catch up the information? So we start with the PFD, the process flow diagram, just like a single line diagram. Okay, I have a heat exchanger, I have a vessel, I have some pipelines which are connected here. A pump is there and a motor is depicted together. Then when we do little more detailed information, like showing, probably give me a moment. Yeah, I can. If you see this, just a blown up view of this, like you will not only see the pipes and all, you will also have something as the instrumentation part connected to it and the control units. If I have a pipeline, I should have a valve to operate to stop the fluid or to increase the fluid pressure or to change the flow, unidirectional or bidirectional, or even if I'm reducing the flow, then the pressure will build up on the inlet side. And what is the pressure which it can sustain and what time you should release it to maintain the pressure. Same thing, once we go with more detailed information, then we find out, like if I need a pump, which is also connected with a motor, then what other things we have? Then there's a flange, a joint connection, then there's a pipeline, which is shown here, and then other things which will come up. But this is actually not the way the manufacturer will provide the item to you. It will be something like, it will look like a finished product which with more information detailed here. So which becomes the level of detailing, something named as LOD 400, LOD 300, 400. So more finished information so that you are actually developing the data in the plant. And later, once the items are ready, they are designed, developed, then we do the documentation of it, like what object it was, what kind of information it has, what is the technical specification of this pump, which is actually only this part. What you see here in this photograph is actually only this part of the pump, not the motor, not the controller, which will be coming as an add-on, which will sit here connected to it. And even this pump needs lots of maintenance work at times. When you want to open it completely and you want to do some repair or maintenance, either the blades are damaged or some fins or some gaskets are leaked or something. So you also create a detailed information, or you sometimes we call them as exploded view, so that you know exactly what will get fitted at which place. Like if you see it further, if I can zoom and control P, sorry, now already zoom. If you see in this view, there's a center line which is just lying like this. So the top assembly actually will be connected and it will go inside this casing out of this. So we are preparing the maintenance and service manuals. And then again, probably you want to refabricate, recreate, or the brownfield condition when you want to revisit the complete cycle, complete process. And it goes from here back to this place. If you want to increase the plant production capacity or enhancement, or after 30, 40 years of life, you want to recreate the new plant out of it. So this process or the cycle begins once again. So here is just a statement which we talk like BIM is nothing but the building information modeling. And this we are talking tradition as a tool for plant engineering. So BIM for plants like Revit is actually civil and architectural area where they do it all the work for the buildings. So some basic idea about the software. When we are talking, the heading what we had today is plant design with a database linked information. So how this database and other things come into picture. So we will see live when Mr. OS will also show you the live screen, or even I will be able to do. Okay. So it is something like a fully integrated multidisciplinary CAE system, computer-aided engineering system. No, I'm not sharing with you. Okay. So it is fully integrated multidisciplinary CAE system. So when we say multidisciplinary, like few slides back, I said it is mechanical, civil, electrical, electronics, everybody integrated. And the design process goes across all the platforms, all the users, and they work together in a single common platform. There will be rule-based quality checking, then the enterprise level standardization about the catalog, part naming, the process, methodologies. They all get captured with certain logical rules. Structured and customized automatic report generation, because everything is coming from a database. You may have used Microsoft Access or SQL or Oracle. Popularly, many colleges have, I think, SQL or something like that. Or we use a version database, which is the object-oriented database, and we define our objects based on that. So this also is becomes part of the report generation where all our information is captured. If it is electrical, then the wires and the cables, they get certain support casing, which is the cable tray routing. If I have a pipeline, then obviously we will have certain supports and the hookups. Probably I can go back here. You see this yellow one, this itself is a support or some kind of thing. Okay, let me set the view properly. Or you can see all these vertical silver lines, which are supporting these green pipelines everywhere, so that they don't fall down on the ground. You are seeing this? Some kind of support, maybe like it is looking like an inverted L or double L, or what is the inverted goalpost kind of thing, like a small size, but vertically goalpost. So there will be some support which will hold them in place. So this becomes a part of the steel structure together. And if we see these platforms, the ladders, staircases, they all go part of the steel structure. Sorry. So many such informations are available. Many type of calculation to reduce Excel errors. You don't need to do calculations manually. It is there fit in the program. You just go and use them. Then we also have certain process documentation. Like I have a pipeline and I need to do some cleaning operation in the pipeline. Maybe I have to clean the vessel because it was operating for maybe 4 months, 6 months, long duration. And later we feel that, okay, the material inside that has little contaminated, or it has become dried out, or not working properly, because too many problems are there, or there may be some scaling inside and we need to clean. So to clean, now my inlets should be stopped, reduced. But if I just stop the inlet, all the fluid coming in, they will stop abruptly somewhere in the pipeline. They will just stop somewhere, and they will cause what is a water hemorrhage or fluid hammers, and they can even distort this complete structure. It is not that easy that just close the valve and we are happy. No, it's not that easy. We need to plan that first fluid coming inside should be stopped. In that case, the fluid which is, or the gas starting from these source vessels, they should be stopped. They should be reduced. Their intake should be controlled here, so that all the way when they travel across, by the time they reach to these vessels, there will be less and less pressure, so that it will be little easy to clean. Sometimes we often also create bypass lines, so that they don't go in the main vessel, but they just escape to some other route, and they just go out of the design, out of the actual thing what we are going to clean. So likewise, there are different processes which are followed in that case. Sorry, that might be a little dry in the past 2 days. Not a problem. I'll just skip this kind of thing. More or less we talked and we have seen some live examples. Okay, so something again about the database. I have, sorry, a symbol which talks about the pump, something like this. It looks like a pump in a 2D diagram, and there is a motor which is connected. Now this motor, when shown in electrical engineering, it is depicted something like this. For a process designer or for a PNID, it will be like this. The motor M, or something quickly. This motor, which is looking like this here, actually it will be shown with like this in an electrical design, where all these three phases, 1, 2, 3 wires, and then there is a grounding. They are shown like that. And when it is connected with the pump in the 3D, it is shown something like this. So this pump has certain data. It has some tagging, the class, then the counting number, how many pumps are used in this. So some number will be assigned. This is pump number 1 or 2 or 50 or 500. So it will do the counting also automatically. Then what temperature and pressure conditions, this is defined so that it works proper. If I say it is for a cold water and a normal pump, and if I start passing some acidic material, the pump will, the gaskets will just, not they will get damaged, and it will, the leakage will start immediately within no time. So cold water to hot water or some acidic media or some alkaline thing which can cause rusting to that. So everything is defined in this, and this is what defines the project database and how it has to be used. And if it is fed in the database, now this pump will be connected to some other thing, which is the fluid here, outlet, okay, or outlet which is defined here. Then the item which is going out also need to understand what information it has. So the data, you see the header probably can show here. It says data input for the pump. So the pump will have some information which is assigned to it, attached to it. And not only pump, but everything. I'm referring to pump as one particular component which is shown in this presentation. Otherwise, each and everything, the vessel will have, all the pipelines will have, each and everything will have some kind of information assigned that way. And you can see some information which is coming to. So CAD data and graphical image, if we just do the work in plain AutoCAD or some CAD program, in AutoCAD or IntelliCAD or any other thing, they have CAD data and graphical image, but later we need to add them with the CAE part, the engineering part of it. So the information flows with the plant structure. So pump will have the tagging, it is labeling, the codes, the information provided in different sheets, which area it is placed so that maintenance time, people can go and find it out, any documentation required. So you can see different type of data which is defined for this purpose, because later they will come to the safety and the maintenance part. I say pump number 501, and you have a 2-kilometer long plant, then you will keep searching, 2-kilometer plant, whether it is here in this place or it is after the 1500 meter position. So you need to know exact location out of it, so that you can go and pinpoint and work there, or you can ask someone else, okay, you are sitting close, you can pick up that pump and see if this problem is there or not. And then, as I said, the VR, the virtual reality, and later also the digital twin part of it. So if we have the CAD model, we can think doing that part. So something like optimized GL layouts. So from the 3D, we can generate this elevation or top view, or we can generate this type of, this is 3D visualization, not saying isometric. Isometric is little different, which we will see, I think, little later. This type of wizards, which are part of the steel structure, we will see example of this also. And how the data is filled and how it works. So we will see lots of things in the live session. Okay, I said about this one, sorry. This object, which is a kind of a steel structure, but when I go to the next sheet, I can show you that here. I have 4 different pipelines running across, and there is a crossover with steel frame, which allows the user or people to move across without damaging the pipelines. So you can see it here also, both the places. Crossover, go for pipe ladder system, Again, go down 5 step down, and you are on the next piece. So ideally, this gives different design activities which happen in the plant. Lots of information provided typed here, but I will prefer OS to do a live session. OS, can you show something quickly? I mean, I have lots of things which I can keep talking, but I think it is more. It will be better if we just have some session live running on the screen and see it.
Yes, sir, sure.
Huh?
So yeah, I'll share my screen.
Yes, I'll keep stopped. Yeah.
Yes, sir. So is my screen visible?
Yes, yes, please.
All
You
right.
see the free thing here. Yeah.
Yes, sure. So yeah, I'll just start off. We'll have our demo, session for the PNID designer. How we can design these PNIDs for your plants, right? Process plants, and how you can create these PNIDs into the 3D using the Cadison software, right? So we'll have a session for that today. Before that, we'll have a brief introduction on the Cadison's PDM module, also known as the Project Document Manager. This is basically where all the project documents are stored. So all the project database is stored here, right? And we can create all these different document groups like folder groups to create the different drawings. Like for instance, we have our PNIDs, your reports, isometrics. All these drawings have different document groups, different folder groups. So with Cadison, you can create all these drawings from here. But what else you can do is you can create your own, you can just import from existing documents as well, like from your system itself as well. So we'll just drag and drop one of the document, right? So let's say we have this particular document from our different user, which is in our system, and we want to import it. So we can just simply drag and drop onto the PDM module so that we are able to, import it in. So here you can see our PDF has been imported. So this way we can import in various format. It can be in image format, in DWG format as well, right? In Word, Excel, all these imports we can do, and we can, have all the documents under one roof. So this is enabled.
Basically, it also helps you to capture the material safety data sheets. Very important. What kind of material you are using and what are the safety parameters defined by an safety lab, maybe like the BIS or in India or any other organization across the world. So you have the safety sheets, you have the manufacturer documents. If he's providing, what kind of document or information he's providing, so that you can control your design parameters, that whether this plastic material will be able to take 100 kg load. No, it will not. So we always need to know such things, how the safety sheets will work, what are the information. If it is a project on a contractual basis, then what are the contract terms and regulations? When is the delivery schedule? Your project PDM or Microsoft project-based documents or anything like that. Yeah, yeah, yes, sorry.
Yes. So along with that, we can do the user management as well, wherein we can create the different users who will be working on the project, right? Like here you might have some existing users, and we can manage their passwords and IDs so that we have, the security of our data, right? So we can create the different users, we can manage their passwords and IDs from here, right? As you can see. Also, we can manage their access rights. So by access rights, we mean that we can manage if the user can, create the project, if the user can delete the project, or if the user can make some changes on the catalogs, right? All these kind of user level settings, they can be handled from here, right? And you can do all these settings for multiple users. You need not do it on an individual level. You can group multiple users under one project which they're working on, and you can do all these settings at one level. All right, so now let us see how we can more draft our PNIDs, right? PFDs and PNIDs. Like if you see a general workflow process for a process design, right? So first we create the PFDs. Out of that, we create the PNIDs, and then we proceed on with the 3D, right? So initial process, we have the PFD, right? So here on the screen, you can see the PFD, and also we will see the Cadison, interface, right? So basically, Cadison is based on AutoCAD, right? Though the users who worked on AutoCAD will find this interface quite familiar, all right? So we have the different, menu bar, we have the ribbon bar, as well as the toolbar, right? And we have the Cadison tree as well, wherein we can filter out all the data in your project. It is one of the most important parts of project, right? Let's say if you want to view all the walls in the project, you can just go to the filter of walls. You will be able to see all the walls in the project, right? Similarly, if you want to view all the equipments and nozzles, so we'll be just able to see all the equipments out here, right? Vessels under the filter of vessels and nozzles. So similarly, we have various filters for different objects. So if you want to view all the heat exchangers in the project, you can do that. If you want to view all the pumps in your project, right, we can do that. So we can configure and customize our own filter as well, right, to view the different kinds of data. So this is how CAD Sentry helps us, right? Below that, we have the tool palette, wherein we can store all the frequently used commands, right? So that you don't have to search for these commands elsewhere, right? And on the right side of the screen, we have the object manager, which is basically the symbol library of the software, Cadison software, right? So if we go in this particular section of plant design, right, we'll be able to see all these different kinds of symbols, which are generally used in the process industry, right? Like heat exchangers, your pumps, right? Your reducers, flanges, valves, all these kinds of objects are here, right? And here you will be able to see all these symbols, right, on the below side.
Oh,
So
yes.
equipments are here. Yes, sir.
Small interruption. So maybe like if we have some vessel and pump connected to a pipeline and size and dimension details flow, so they will get a better idea, like about the database, the data transfer across the items, and
Yes, sir.
and then we will see if we can drag and drop one or two items directly to the 3D and connect something. Yeah.
So here we have one of the pumps, right, as sir was mentioning. So once we edit this pump, you will see that it has its own data form, right? So with Cadison, all the objects have their own data form, right? So when we say these are the symbols, so these symbols are all intelligent symbols, right? So by intelligent, we mean that all these symbols have their own data, which is the metadata, right? And as we were saying, with Cadison, there is some intelligency wherein the objects will borrow data from the other objects, right? So yeah, like here we can see, right? So we'll just route some pipelines and we'll see how this data is transferred from one object to the other object, right? So for instance, let's say I want to create a pipeline. So how to do that? We have the wizard for the standard pipeline, wherein we can select the media which we want to create. We can select the pressure rating which we want to generate, right, as well as the nominal size. So once that is done, we'll just say okay, and we can select the start point as well as the trace line, and we can select the end point as well. So our pipeline is ready right now, right? So here you will see that our pipeline is there, and now let's place some inline components onto the pipeline, right?
Uh, can you undo it and do it again so that we can also
Yes.
show the Cadison Explorer? So in the pipeline start and the end connection, that green box. Yeah.
Yes. So
Yes, I
here
just
we select all this particular data using the drop down, right? Once we do that, here you will
wait,
see that we
wait,
get the
wait. Now here, probably you can see, just keep this. So it's, if you can enlarge, it says from where it is starting. So it is showing the uh, P160 and the object 2 is a pump which is there. Object 1 belongs to pipe 944, which is a pipeline for monochloroacetic acid. Yeah, good.
so so all this information is mentioned here as sir is saying. And once you select the start point, and now we want to select the end point.
Just hold before the click. Yeah, hold it. Now it is changed to green. It is understand, the software is able to understand that being the object-oriented database-backed system, it is able to understand that the first and second points are defined and now pipe should terminate and it is showing in the green color. Earlier it was yellow. And now probably if you can zoom your screen somehow, you will be able to see. It says object one is pipeline connection for object with one nominal size, and object two is a nozzle which is having a dia of size dn 50, mean diameter normal 50, which is basically 50 mm or 2 inches of size, corresponding size. And this will be connected to a reactor with 10 bar pressure. So all such information is displayed in the software instantly. Yes, please, now you connect.
Yes. So now we connected the endpoint and we'll just say okay. So our pipeline has been routed, right? And all this information it is showing, right?
So why is he saying pipeline? He did not say a line or something like that. If he's saying, OS is saying it is a pipeline. So what does it mean? Is it referring itself to as a pipeline? So can you just right click and edit, and you can see pipe route and the pipeline object. And everywhere it is talking about the pipeline for uh, monochloroacetic acid, partly cut behind next to that. And it is showing all such information. Probably you can see line number 4 or 5 where it says media, small size media. Can we make it little large? Okay, I can read, no problem. So it says monochloroacetic acid, which is the media which is supposed to flow through it. And all the size, dimensions, the temperature, 14 degree, what is that? And then the 33 bar pressure, then
Pressure.
all the connections. Yes, all such information is displayed together. So that the designer, when he's doing, he will instantly get the information. What is he doing? Is it good, safe, or something else is happening, something wrong he is doing? If he just draw lines and all, he will not know any design parameter, anything which can change the design. He will not know. Yeah, please.
Also the information such as pipeline from. So from which equipment the pipeline is coming. So we saw that it is connected to one pump, right? At the start, which is the pump 160, right?
Yeah.
And then later on it is going to the equipment B5, right? And the nozzle one of B5, right? So that way it is updating the data automatically as well for the other objects, right? So Cadison follows this philosophy wherein some objects borrow the data from the other objects which is supposed to be borrowed, right? So here you see that some data has been updated automatically, right? Now we have created this particular pipeline, right? Now let's place some inline components onto the pipeline, right? So here we have the different symbols. We also have the walls, right? So we can just place some walls onto the pipeline. So once I expand this wall segment, you will be able to see all these different folders for different types of walls, right? So based on our requirement, we can just simply select the folder which we want to route, right? And once we select the gate valve, we can just place a gate valve onto the drawing now. So we just simply have to drag and drop onto the drawing, right? So here I have my valve on my cursor, right? And whenever I drag this valve onto the pipeline, you will see that it changes its orientation automatically according to the pipeline, right? So now we'll place this particular valve out here, right? So once I place the valve, you'll see that it cuts through the pipeline, right? So
And
it, yes,
and it also got a number V835. It is saying in the current design or current database, it is the valve number 835, which I was talking earlier in my presentation, whether it is 1 kilometer long pipeline and I have to find something after 1 kilometer or within close to that area, then I should know where that valve is positioned. So immediately it has found the position and the tag number, which is V835, the pipeline information and the valve information. Yeah.
right. So this is taken automatically. The tag is taken automatically, and when we place the valve, it cuts through the pipeline. So it means that it has been fit with the pipeline. And again, now this valve will also borrow some data from the pipeline, like the media you see here, right? So when we place the valve onto this media, right? So that time it borrows the data for the media as well as the pressure rating and the nominal size, right? All this information, if you recall, while routing the pipeline, we have given to the pipeline, right? And once we take this valve away from the pipeline, let's say, so you'll see that the pipeline fills automatically again, right? And now if we edit the valve, right? So you'll see that that particular data which it had borrowed from the pipeline, it won't be there, right? So in order to showcase the data, the pipeline and the valve should be connected to each other,
Yes.
right?
So it just shows like the data flowing through the data from the database and interconnectivity. The moment it is connected, it will know, okay, I am having so much of information coming from the source and the server or the pipeline or the database. And if I'm not connected, independent, then pipeline is automatically filled up, the main process happened. So user also did not have to, oh, some line is broken, something wrong happened, and nobody knows. So you will end up doing costly quality inspection, checking where is the fluid leaking out of it. At the same time, the details are also updated. Yeah, and now we can bring it back on the same position and then see.
So we'll again bring it back to the same position, right? We can move all these objects using the move command, right? Once we do that, you will see again it cuts through the pipeline. And again, if I edit the valve, you will see that the data is shown again,
So
right?
process standardization, no typing, nothing, minimum typing, at least some information sometimes you need to fill, but at many of the information coming from the catalogs or backend systems or from the database where user did not have to even type something of his own. I will like pump of, let us say this is valve of some capacity. Somebody else will say it in different valve, comma, uh, DN50, comma, some information. So there is a difference in all style of writing the information, which changes. So they all look different. If it is small one or two item, fine. If it is hundreds of them, it will be difficult. So we standardize the process also. Yes, yes, please.
Right. So also we saw the auto-generated tag. So we follow the tagging philosophy of DIN tagging philosophy as well as KKS, right? And also the customers have their own freedom to configure their own tagging philosophies. Okay. So yeah, this we saw for the auto-generated tag. And now let's say if you want to showcase other properties of your walls or let's say your pipeline or equipments, right? How to do that? So Cadison offers a solution to that using the object designation. We can select the object which we want to designate. It can be any particular objects from all these, right? For instance, we have our pipeline, right? So I want to, showcase the data of the media for the pipeline, right? So I can select from this whole list of different properties here. I can just simply type M and it will take me to the M section where I have the media, and now I want to showcase the media tag in the vertical form, right? Now I want to showcase the media of some pipeline, right? So when I select the pipeline, it will showcase the media of that particular pipeline, which is in this case the monochloric acid, right? And again for this particular pipeline, it's sodium hydroxide. So this way you can select any particular property and you can designate your objects, right? But Cadison also offers the option to configure your own tags, right? You can have multiple properties under one tag. For instance, we have the pipeline number where we have the properties like media, the counting number, right? The nominal size as well as the code, right? Now I want to showcase the pipeline number of this particular pipeline, right? I'll just simply say apply and select the option, right? So here we have just place the tag for this particular pipeline. Similarly, you can do it for multiple objects at once, right? So what process we have followed for the pipeline can be followed for other objects as well. We just simply have to select the object to mark, and the properties for that particular corresponding object will showcase in this form, right? So that we can designate. So sometimes the engineer have these requirement wherein they want to showcase the data in a tabular format. So we have the provision to do that using Cadison. Let's say I want to showcase the data of all my pumps, right? So I'll just simply select all the pumps in the drawing, right? And now I want to just place the tag automatically. Here all four of my pumps have been loaded on this form, right? So once I place the first two tables of the pumps, right? The rest of the tables will follow through. So here we have the pump A to pump D, right? And they are showcasing some information like the power, the voltage, as well as the power factor. So you can choose and select from whatever properties you want to showcase. It can be some other property as well. And what we are doing it for the pumps, it can be done for the other types of objects as well. Be it your equipment, be it your, pipeline, whatever, valve. All these objects can be showcased data with the tables, right? So now we are done with the designation part. We come to one of the most critical parts of the project, which is the data entry, right? So as we saw with Cadison, we have all these objects. You can just simply go to their edit forms and you can enter the data, right? But let's say you already know some data for your pump. Let's say you already know which particular type of pump you will be using, right? So what we can do using Cadison is that you can have some pre-configured list for whatever requirement you have, right? Let's say you're using the pump from the manufacturer alpha level, right? Already you have some information showcasing that particular pump, right? So you can just save all these options you have in a list, which is a pre-configured list. And once you select the option, you will see here that the data is updated automatically for multiple properties, right? So this way you can make bulk changes onto your data. You need not fill in individual properties, right? And also when you're filling these properties, you are filling the properties individually per object type, right? So with Cadison, what you can do is you can fill in multiple data for multiple objects at once as well, right? Let's say I want to fill in the data for all the pumps in my project, right? And here we have this table which can be configured. You can include whatever property you want to include in this table, right? We can configure that and customize it. But let's say I want to showcase some information like a project description and I want to change that data, right? So here we can give some prefix, let's say P dash, right? The prefix is for all the pumps, right? And then we want some numeric sequence or alphabetic sequence, right? We can have a numeric sequence, and I want the pumps from 6401 to 6404, right? So I'll just simply give in the target value, and once that is done, we'll say OK. And here, if you notice, once we say OK, the data for all the pumps is changed automatically, right? So you can make changes on n number of objects at once, right? Using the option of fill n number. All right. So now we are done with the part of, the data entry. We come to the part wherein we check if our data is error free or not, right? How to do that? So here we have two equipments, right? Which is B2 and B3. Let's create an error of our own to check all this data, right? So here we have the B2 and now we'll change the tag of the B3 to B2, right? So now we have the case scenario wherein we have two equipments having the tag B2, right? So it gives us an online check saying the device tag is not unique. But let's say due to some time constraint, the user goes on and now we have this particular data error and the user doesn't know where this data error lies, right? So what we can do is we can run the logical check on the project level, right? So Cadison has multiple logical checks available by default, like checking the pressure ratings of the walls, checking if the objects are present in the 3D and the PNID, right? All these kind of checks are there. One of them is the uniqueness of equipment codes, right? Once we run that particular logical check, you will see that it shows us the error that this device tag is not unique, right? So you can highlight these objects from here itself, right?
Can
So
we
in the
can we zoom
background,
can we zoom to the first one and the second one?
yes, sir. So
Make
here we
first
have
zoom
highlighted it.
first zoom the PNID smaller, make it like smaller. Other way. Zoom out, yeah. And now we say show. Yeah. So it is automatically going to find it out, even if it is a small drawing or a complex drawing, thousands of items, but it will zoom and show you exactly that this is one of the item which is in the process of question, which needs some improvement. Yes. Check the other line.
Yes. Also, we can change the data as well. We can rectify our mistake. We can now change it back to B3, right? So once we do that, you will see that it is reflected here, which is B3, right?
Yes. And it is not
And
one or two components, it could be hundreds of them. If any problem has happened, it will list all of them that this problem is found with these objects.
so now if we run the logical check again, it won't show us the error.
So it
All
should
right.
be error free. Yeah. So there is no item listed means design is proper that way. And it is error free now.
Right. So sometimes you're working on plants like water treatment plants, right? As well as, the skids, where all these assemblies are frequently repetitive, right? Like in this case, here you can see this assembly, which is repeating again and again, right? And here also we have an example of the control assembly, which is at multiple locations, right?
Bypass lines.
Yes. So what we can do, we can save these assemblies as construction sets, and we can use it whenever it is required, right? So here we have this particular construction set of the control assembly. So once we say okay, we can place that construction set onto any particular drawing pipeline. So here we have this particular pipeline, we'll just place it there, right? So at the start of the project process, you'll see that the pipeline is white colored, right? But now that we have placed it onto the yellow color pipeline, once we update the objects, you will see that it considers the data from the pipeline where we are placing it, right? It will consider all the properties like the media, the size, the tags of the particular walls and the components. All this will be taken care of, right? So this helps us save a lot of time, you don't have to draft these assemblies again. Whatever is repeating, you can just leave it for the construction sets, right? So we are creating all these drawings and we are also filling the data, right? So how we can use this data for our benefit? So with Cadison, we can extract multiple reports, right? So we have the option to create the reports. We have the wizard for the reports, wherein we have multiple options for reports. Like we can create the fluid list, we can create a pipeline list, MTO, wall list, all these kinds of reports we can extract. And also we can extract in Excel as well as Word format. So for now, what we'll do is we'll extract this wall list, right? Also, we can give the directory here where we want to save that particular reports. So whatever directory we give, the drawing will get saved into that particular document group, right? And also when we create these reports, we can create them in multiple formats like your Word and Excel, as well as a PDF. And yeah, here our wall list is ready, right? You can see all these walls have their own data, like the tag number, the description, material, manufacturer, type, medium, and all these properties are there. So with Cadison, while extracting these reports, we can customize our own reports as well. So let's say you all wanted some other properties to be included in the reports. We can create that, the template for the report, and we can extract these reports with multiple properties, inserted properties as well. Also, the whole template itself can be customized. Let's say there is some company logo, the client has some different logo here. So we can include that particular logo, and also they can customize their own tagline. So the whole template itself can be customized, right? So when it comes to, sharing of the data in Cadison, so we can share data from, and import it back along with the changes as well, right? So let's say we want to export some data to for our user or clients, right? You want to showcase the data for the walls, right? We'll just load the walls and we can export the data, and then maybe the client will make some changes onto the data, right? Whatever changes they feel feasible. Let's say they want to change the manufacturer from Emerson to Inox for all the walls. So we'll just load the data here, and we can just simply save the file onto our system with the name of VL33. And once that is done, we can go back to the Cadison environment and import this particular changes with along with the changes made. All right. So here we have the import button wherein we can select the document which we created, and we can say open. So it asks us if we want to validate the changes that have been made or no, right? So we want to validate the change, so we'll say with, and we get this particular wizard wherein whatever changes have been made will be reflected in a different color scheme, right? So it is easier for the users to understand whatever changes have been made, right? So in this case scenario, we changed the manufacturer from Emerson to Inox, right? So here you will see that all the Inox section is colored out in yellow, so that it makes it easier for you to understand whatever changes have been made. So you can ignore some data here as well. We can change it, and once we import validate it, it will change to green color, right? So just validate, let's validate all the data at once, and then maybe we can import onto the database, right? So once that is done, it will be reflected in the drawing as well, right? So whatever walls we have, right, here you will be able to see the manufacturer has been changed to the inox from Emerson, right? So it is reflecting in the database as well.
So can we quickly update the report file? Because this
Yes,
is what we talk, like data flows seamlessly across the applications, across the objects. Yeah. So we had the report a few minutes ago. And now
yes,
the
sir.
new report, if we regenerate or you say update the report, is to show that it is having the Inox as the manufacturer of those ones.
Sure,
Or
sir.
just recreate quickly, just recreate a new one.
So I'll extract the wall list again. I have not saved it in the database, all right?
Okay.
And then we can make some change and then extract the report revision. So here we can just simply select the insert database option, and we can select the document group where we want to extract the report. So we can just save it in the report section, and once we are through that, it will automatically get saved in that particular folder group, right? And then we can extract a revision as well out of that particular report. All right. So now let's make some change here so that we can just create a revision as well.
Okay.
So I have this.
For now, just show the Inox in the list in the sheet.
Sorry, sir.
And just show that Excel sheet showing the one which is generated now.
Yeah, sure.
So instead of some other manufacturer, now it should show Inox, the Excel.
So we'll just extract the
Is there in the taskbar, the last one.
yes. So here we'll just simply say update report, and we can create the revision as revision A maybe change in manufacturer. All right. So create the revision. We can just simply say. So it will just simply create a revision, and we can get access to these revisions once we use the drop down for all documents and revisions. In that filter, we get the access to all the revisions which have been created, not only for the reports, but for our drawings as well. So you can do revision management for all these drawings as well, and you can get access to all these revision reports there. All right. So here you will see the manufacturer has been changed to the Inox now, right?
Yes. So now quickly what we can do that we can go to the 3D mode and
Yes,
maybe
sir.
drag and drop one or two of those pumps and these things.
So
So that
this
they
is
also get an idea 3D that we are not only showing them the already created file, but something they can see and 3D integration happens, how we can extract the data or move across the disciplines, why we call multidisciplinary. Yeah,
so as you
something
can
small.
see, this is a huge 3D model for a plant, right? Which has been loaded in the created in the Cadison, right? So Cadison operation is quite smooth as compared to other softwares, right? Now what we'll do is we'll start off by creating an equipment, right? How we can do that. So we have the tank assistant, wherein we have the different options for vertical vessel, horizontal vessel, or a special vessel scenario, right? So we can just simply create a vertical vessel. We can save some configuration files for the future as well. So here we already have a file. Let's say if you have some, equipment which is having the same dimensions, multiple equipments having the same dimensions. So what you can do is we can save these configuration files and use it for the future use, right? And now the question arises, we have created the equipment in the PNID as well. So how to link that with the 3D model? So here we have the link button, wherein we can just simply select the equipment which we want to link from the PNID, right? Now we just simply have to give the coordinates of our equipment. Once that is done, we can just simply say OK, and you will be able to see that in the background, the equipment is getting created, right? So this is how we can create equipments. We can also import equipments from other software in various formats, right? Using the CAD import button. And as you can see on the screen, this equipment we have created in the SolidWorks, and we are able to convert this equipment into a Cadison object. So it will have its own data as well, and it will be an intelligent object. So we can import these equipments or other objects with along with the connections as well, so that we can connect the pipelines or any particular object to that. I'll list tabs vertically. So on the right side we have the PNID, and on the left side we have the 3D model, right? Now will I recognize what pipeline we want to route, right? It can be this particular suction pipeline. So we just simply have to select the suction pipeline and we can drag and drop onto the 3D model, right? So once that is done, we can say yes. And now we want to route this particular pipeline in the 3D, right? So here you will see that the wizard which we used for this standard pipeline, it is showing again. Just the difference is that the media and the pipe specification is locked. It means that the data has been taken from the PNID itself, right? But there can be branch size of multiple sizes, right? So this is free. So now we just simply have to give the start point. We can give some spool, and now we can use the automatic router option to calculate an automatic route for our pipeline. We just simply have to give the start point and the end point, and it will calculate a route for you, right? So here you will see that our pipeline has been created along with the counter flanges, right? Now let us place this particular valve in the 3D as well, right? So this valve already had a catalog attached, so we are able to place that particular valve as well in the 3D model, right? So this is how you can create your pipeline and you can place the valve as well.
Can
Now
you,
when we say it is integrated,
yeah.
you will see that once we edit the valve, right, it will have a tag of V218, right? Like similar to this particular valve in the PNID. So it is nothing, but it is the same valve, right? There is the same data is the same, but there is different graphical representation in different modules. Like here we have the PNID representation, and here we have the 3D representation. All right. So once
Yeah.
we makes the change in the PN 3D model, like we have 218 here. So let's say I want 318 now. We can change the tag of the valve, right? Once we say OK, and now once we go to the PNID, you will see the tag of the valve changes automatically in the PNID itself.
Yes, because in the back end, it is referring the same database. So editing in any of those modules, whether it is a 2D in PNID or 3D, what we see right now. So it is updating the same data, same object basically. It is not editing a line or circle or just a solid body. It is editing the actual database which is connected behind these objects. So it reflects everywhere. So a person in the actual plant, he will get the same data as somebody sitting in the design house and design row and doing the changes. Or the electrical person who is going to create a motor for the pump and vessel. Electrical engineer also will get the same data that I'm working on this particular pump and the motor connected to it. So there will be no difference in the data as such. So it should not happen that he is working on a 5 HP pump and the other person is working on a 15 HP pump and both of them are saying, no, no, this is the one what you had in place. No, we are talking about the same object. So the database always updates together at everywhere, irrespective of the representation in 2D or 3D or in any of the applications. Yes, yes, guys.
Right. So here we created a pipeline, right? And we saw how we integrated the pipeline as well from the PNID and the valve as well. Similarly, we can integrate multiple objects, not just these two. So we can integrate it along with the PNID itself. Now that we have created the pipeline and the valve, let's place a support for our pipeline, right? So we have the wizard for the support construction, wherein we can select from all these available options like creating a goal post, inverted goal post, cantilever. All these different kinds of supports are there. We can just simply select from here and we can load the information here as well, right? And similar to the equipment, we can save the configuration files as well, so that you can use these files for the future use whenever required.
Can you quickly also call the catalog for one of those items, the IBM or something?
Yes.
Click on that image. Click on the image.
So here we can select the beams and all, right? So here we have all the catalogs, right? So Indian standard, American standards, European standards, all these are already loaded here. And here you will see that this
Keep
information is
expanding.
shown.
So if you click one, then people can see the item or configurations we have defined in these catalogs below. So you see the different sizes. Okay, this is showing kind of things to me as imperial. No, MB 150 to say by 75, 175 by 65, something like that. So lots of data which is provided, and each one catalog will have about 30, 40, 50 lines of sizes which are actually available. These are all manufacturable, not manufacturable, but these are available from manufacturers as a standard item. If I go to market, I will say, give me 1.25 by 2.25. He will not say, he will not provide me because they are not available. They are defined either 1 by 2 or 2 by 2 or 2 by 3, something like that, standard sizes. So these are standard items which are provided in the list, not anything, because fabrication is little different where we can cut and fabricate. And standard items are which are readily available out of the counter or out from the stock item. So these are all stock items which are provided. So this list directly refers to them. And if you go and say, give me this item for purchase, you will get them quickly. Final fabrication updates is a separate thing. Yes, yes. Yeah. Just cancel it. I wanted just to show the catalog.
Yes, now we have loaded the configuration file. We can just simply place our support, right? So here we have the T support and we have placed it under the pipeline. Similarly, we can create the primary supports as well for the pipeline. So here you will see that there are different support options, right? We can have a preview as well. Like we can just simply say show. So here you will see the shackle is there, U clamp, right? And we have the conduit clips as well. So all these primary supports also we can configure and create. All right. So our pipeline is ready and our support is also ready. So now the you must be aware of the hookup drawings for the support, the installation drawings,
Let's
right?
connect that U clamp also. No?
Yes, okay.
Okay.
So we'll create a primary support in the shape of a U clamp now.
And it
So
will
we can
find the size also automatically. You don't need to select the size. It will know what kind of pipeline it had. It will adjust.
So here you will see that the pipeline was 65. So automatically it is adjusting to that particular size.
It is only showing that size which is available or required basically. It is not showing other sizes. Yes.
So we can place it onto the pipeline. When it changes its color to the color of the pipeline, you can say that it has been fit with the pipeline properly.
It is linked to it. Otherwise, it will show gray or silver color. But if it is linked, it will change the color, showing that it is connected to that. Yes.
Right? This is how you can place the primary supports. And now what we can do is we can just simply create the hookup for the support as well, right? So we have the wizard for the create hookup, right? We can create hookup per type as well as for individual objects as well. So let's create the hookup for all the T supports in the drawing, right? Once we say OK, I will just get a preview of your hookup and it will get saved in the database, right? Automatically. So here we can just simply go to the data using the Cadison tree and we can now view the hookup drawing, right? So here we have the graphics for the T support, right? All it is mentioned in the parameters and all these parameters are helped useful to showcase the dimensions, right? And here you will see that all the tags are here as well. So all the dimensions are shown, right? As well as some specifications, what type of beam or channel is used, that will also be shown, right? The plates, which plate is used, the orientation, and all this information is shown there, right? So this is how you can create the hookups. And also creating isometrics is an automatic process using the software, right? So we can just simply say create isometric. We can select it graphically, right? And we can give the data, the place where we want to save the drawing, right? So we can highlight our pipeline, right? We can highlight have a preview of our pipe isometric as well, and we can create that particular isometric. All right. So we'll now create the isometric here, and it will get saved in that particular database there, wherever we've given the directory, it will automatically get saved there, right? So we'll just, open the isometric.
where the split point, so it fits properly. Okay, at least you will always get the idea. Or you can open some existing other one. Yeah.
Yes, we'll open some existing isometric. Here we have the folder group, right? And here we can open the existing isometric. So with Cadison, we have the USP to create the isometric along with the 3D visualization as well, right? So here on the bottom side, you'll see that there is some 3D representation of the pipeline, so that it is easier for the fabricators, who are working on site. So it is easier for them to understand what kind of pipeline is this, right? And we have the isometric graphics here, right, along with the dimensions and as well as the tags.
You can show the joints and weld points and all that.
Yes, so here we have all the weld list,
No, no, in the
and
graphics,
in
yeah,
this,
here, make it large. So there a specific way of showing these symbols in the isometric drawing. So you can see a yellow colored valve. No, just let it. Yellow colored valve, and there are two flanges. Then there is a red colored round circular object, number 4, that is showing the weld connection that they are welded there. Yeah, move little bit. And the dimensions provided to them so that the correct length is defined. Now this pipe is continued on the other drawing. So just enlarge that area. So it will also show that isometric sheet number 1 or sheet number 2, like kind of information. The right side one, make it larger. Right end, yeah. Top, right top, iso line.
sorry,
No,
sir, this is only one sheet drawing, sir.
no, that's okay. Show the right top of the pipeline.
Okay.
Yes, make it larger. So it says connection to this part to another pipeline, which is PU H0P, and the elevation and north position is also shown in terms of meters. Elevation 0.435 meter. So this way it shows all such information with which a pipe fabricator or the spool person who is working on that, he will know how this has to be connected or fitted in the final pipeline assembly. Same way we can go to the other side, other end of this pipeline. And there also, yeah, correct. So it says connection from this, and the elevations indexes will be different. It says 1.10 meter. And then left block, it says F3, G4, B567. So F is flange number 3, gasket number 4. Then the B5 are nothing but the bolts, bolt 567. So the left block, yes. So all such informations are provided. And there is a north shown on the top, which is north of the actual fabrication work. North indicated to actually, it is showing a northeast, but that relates to the plant north, not the actual directional north. Yeah. So this way, all such information is captured, stored, and this is how the fabrication happens, the production activity happens. The right side, there is a bill of material used in this particular isometric, all the items which are used and the quantity and any size and all they have. Okay. So pipe DN, EN, so DIN EN 1026216 is the standard number, which it is referring. It is seamless pipe. So you can read it easily. 15D elbow, 90 degree, then 76.1 by 2.9 thickness, and the DIN standard which it refers to. Then there is a weld neck flange. There is gasket, like that. Each one is detailed. So when you go and work, your inventory should be ready in hand, and then you start the work. So all such information related to fabrication, manufacturing is provided ready in hand. So that's what in the beginning, the first line, if you remember with me, that there may be thousands and thousands of drawing, not just one or two A3, A4 size sheet or A0 size, and saying that my today's work is ready. No, it is just only one of those thousands of them. And that is why we need the complete document management system, the PDM and the project engineer utilities, which help us move across all these items and help us to work with that. So hopefully we have had some good idea about the plant design process and the database activities linked with such applications and the design activity, the 2D and the 3D, how the design changes, how objects behave, interact with each other, what kind of data they receive and create. So I think it was a good overview. Obviously, when we take 10 to 15 days for the proper training, spending 1 hour, 1.5 hours is just a small idea overview only. And if you have some quick questions or get some idea, then it is fine. Or maybe some other time, some other day, we connect for longer and we can discuss more and more out of it. Any quick questions? Or I will think differently that you didn't understood anything out of it. We spent 1 hour. First, unmute. Unmute. Everyone is mute. Any questions? Any? Okay, you can type, I guess, or you can raise your hands. I think in the bottom line of this thing, Webex tool, there is a raise hands option. Okay, so I think we are almost 1.5 hours, and possible because the data which is generated from the pressure equipment or thermal equipments, yes, certainly somewhere the data is generated, and that has to go to some of the IoT applications also, because we want those data to be brought to us on the control panel. And historic data, long time data, because this is the source of the data which starts from here. When I say my plant is running, the plant will generate variety of data at each and every point. It is not just the regular computer IoT or thing what you may have understood earlier, but data is there, and certainly yes, there has to be a dashboard, there has to be a presentation, and there has to be a monitoring of the processes based on that data. So it is useful, certainly useful. I said even the digital twin. Yes. Okay, Ashish. So thanks all, and thanks to us also, as he spent good effort. He did good effort later, because we have started doing an Cadison Academia program, and we would be connecting with certain colleges and lecturers also later. So we will be connected. Thanks all. Thanks once again.
Sir, I guess there is one more question from Harshit.
Harshit, okay. Because my chat window is somewhere not visible. Let me see. It is not showing the caption. Probably I am okay. Yes, chat is shown in the bottom. Yes, now I'm seeing. Oh, Sandilia's learning LTM. Yes, now I can see. Yes. Harshit, acceptable simulate IoT devices? Yes, certainly yes. Could you please suggest some platform that can help us design a digital twin? Okay, so first thing, this is the one which is the first part where the CAD model or the 3D geometry should be available. And then you can use AR/VR tools also, because we can export it later to, what was that? Okay, to one of the VR applications, and there you can connect and link it with that, so that the actual plant activity can be captured and it will be simulated further. If you remember, I mentioned one example, that the current plant running at a capacity of 50 tons per hour production or per day production, and which has to be increased to, suppose, say 500 tons per day production, which is too high. Let us say 50 to 100. Okay. In that case, we would be able to simulate it completely within the software. And that is what the advantage is. So first, the actual CAD model should be there. We should be able to see the functionality. We should be able to see the flow of data across the equipments and the system. And then we can simulate the digital twin. The twin, which is in the real life, and the one which is created in the virtual world from the CAD. So the 3D simulation is certainly needed. Yes. Thanks, Arshit. So thanks again. And thanks all. And I'll disconnect now.
Thank you, sir.
Thanks all. Bye. Bye.